Solving for a variable. Our goal is to be able to solve any equation for any variable that appears in it. Let's look at a simple equation first. Here we have 8 equals d divided by t. The variable in this equation is d. Solving for a variable means having it alone and on the left side. So when you see the directions to solve, that's what your goal is. So right now the equation is not solved for a variable because the variable is on the right side and it is not alone, it is divided by 10. Like in any game, there are a few rules. There are 4 rules which will allow you to solve any equation for any of its variables in most any of your subsequent mathematics and science courses. So learning these rules and how to apply them now is very important since they will follow you for years. And you can always fall back to these 4, no matter how complicated the equation gets. Here are the 4 rules, but instead of just reading through them, let's examine them one at a time. The first rule is to undo a mathematical operation, you must do the opposite. We learned earlier that for every mathematics operation, there is an inverse operation which undoes it. When you do both operations, you get back to where you started. For example, addition has subtraction is the inverse operation, addition and subtraction. Multiplication and division are inverses. Those are your most popular, but there are many more. But it just undoes where, and you get back to where you start with. When the variable for which we are solving is connected to something else by one of these mathematical operations, we can eliminate that connection by using the inverse of that operation. The second rule is you can do anything you want except divide by 0 to one side of an equation as long as you do it the same to the other side. You have to keep your equation balanced. If the two expressions on the opposite sides of the equal sign are equal to begin with, they will continue to be equal if you do the same mathematical operation to both of them. This allows you to use an inverse operation on one side to undo an operation as long as you also do it to the other side. So if you add 2 to one side, you have to add 2 to the other. If you multiply by 3, you have to multiply 3 on the right and the left. You have to just do it to both sides. You have to keep the equation balanced. You can just never divide by 0 or by something which turns out to be 0 since the result of that is always undefined. So again, anything you want except divide by 0. The third rule is if there is more than one operation going on, you must undo them in the opposite order in which you would do them, the opposite of the order of operations. So the operations which are connected to a variable must be undone in the reverse order of the order of operations. Remember, order of operations was with PEMDAS or GEMDAS. So when you're solving for a variable, you first have to do the addition, subtraction, then multiplication, division, then exponents, then parentheses. So it looks like the opposite of PEMDAS. The order of the steps you take to untie a knot are the reverse of the order you use to tie it. Think about your shoes. You want to think about that just as you untie your knot in your shoe as you tied it. You want to undo PEMDAS as though you had done it in the first place, always keeping that opposite order. The fourth rule is that you can always switch the left and right sides of an equation. Once an equation has been solved for a variable, it'll be a lot easier to use if that variable is moved to the left side. Remember, that's always our goal. So mathematically, this has no effect since both sides are equal, but it's easier to use the equation if the side for which you are solving is on the left and the values are substituted on the right.
Let's solve this equation for D. Solving the equation means that when we're done, we'll have D alone on one side of the equation. At the end, we want it to say D equals. So, what's the first question? First, is D alone? If not, what's with it? It's not alone. D is currently with the number 10. What mathematical operation connects them? Multiplying by 10 is the opposite of dividing by 10. If we multiply the right side by 10, what must we do to the left side? If we multiply the right side by 10, we must also multiply the left side by 10. All right, well, is there anything else with D? Rule number 2. Remember, you can do anything you want except divide by 0 to one side of an equation as long as you do the same thing to the other side. There's nothing else with D, only the 10. If there's more than one operation going on, you must undo them in the opposite order in which you would do them. So that would be the opposite order of operations. So PEMDAS backwards. All right, let's go ahead and solve this equation for D.
Applying rules 1 and 2. Rule number 1 says to undo a mathematical operation, you must do the opposite. So here we have an equation 8 equals D divided by 10, and we're trying to solve for D. So we need to think of the opposite operation of dividing by 10, since we're trying to undo the dividing by 10. Rule number 2 says that you can do anything you want except divide by 0 to one side of an equation as long as you do the same to the other. So here, if we're trying to undo D divided by 10, the opposite would be to multiply by 10. And since we want to use rule number 2, we also need to multiply both sides by 10, which we can see down here. If we're multiplying both sides by 10, that is now undoing the dividing by 10 and leaving us with 80 equals D. This equation is now solved for D, even though it's on the right. Now, traditionally, as we'll see with rule number 4, we can always switch the left and the right sides of an equation because typically it's more common to see the variable on the left-hand side. So we're just literally the equation sign stays in the middle, and we're switching the variable and the 80. So 80 equals D is the same thing as D equals 80. Again, both equations are technically solved for D. It's just more common practice to see the variable on the left-hand side. When solving equations, the goal is always to isolate the variable on one side of the equation in order to determine its value, and that's the value that makes the equation true. So, for example, x plus 7 equals 32. Our goal is to get x, the variable, by itself on one side of the equal sign. So here, we really need to use inverse operations, or those opposite operations, to do that, to solve for a variable on one side. So here we have the first one, y plus 7 equals 14. If our current operation is adding 7, our inverse would be the opposite of adding, which would be to subtract 7. Here we have b is a minus 21 equals 10. The current operation is subtracting 21. So we need to do the inverse or the opposite of subtracting 21, which would be to add 21. In C, we have 5 times S, or 5S equals 25. We have a current operation of multiplication, multiplying by 5. So we need to do the opposite of multiplying, which is divide by 5. And in D, we have x divided by 12 equals 5. So current operation is dividing by 12. The inverse would be to multiply by 12.